Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and the question belongs to paper 9709/41 for the session May June 24. And question number 1 says a car starts from rest and accelerates at 2 meter per second square for 10 seconds. It then travels at a constant speed for 30 seconds. The car then uniformly decelerates to rest over a period of 20 seconds. Question number A says sketch a velocity time graph for the motion of the car. Look at the question. They have told us to sketch a velocity time graph, whereas there is no precise information about velocity. So what we should do at the beginning is to find the velocity. So let us find velocity. We know the concept of a velocity is equal to u plus a t, and our initial velocity is 0 because it started from rest, whereas the acceleration is given 2 meter per second square and it continued till 10 seconds. So what is our v? Final velocity is 20 meter per second. 20 meter per second. So let's start sketching. And you know x-axis is applicable for time. So we will write here t second in the x-axis, and along y-axis it will be velocity meter per second. Well, then we have already found out that 20 meter per second was the velocity. Let it be 20 over here. Okay, then let's read the question once again. The car continued moving with the uniform acceleration until 10 seconds. So first 10 seconds, let 10 be over here. Then it travels at a constant speed for 30 seconds. So 10 plus 30 means it will be 40 seconds. Let it be 40 over here. Okay. After that, in the third phase, the car then uniformly decelerates to rest over a period of 20 seconds. So 40 plus 20, it is going to be 60 seconds. So there are three phases. So first phase is here 10 seconds. Then until 40 seconds, it was moving at a constant speed. Then last of all, it came back to rest. So let's start. As it started from rest, it will start from 0. Let me show this. We will just join this 2 point. Then for constant speed, for constant speed, the line will be parallel to the horizontal axis, and from that point it is coming back to rest at 60th second. So this is what the sketch of the scenario is. Let's move on to the immediate next question. Question number B says, find the total distance traveled by the car. We know how to find the travel distance of an object. Travel distance is nothing but the area of the region the car traveled. So let us find the area of the region. So we will write total distance. Total distance is equal to total distance is equal to total distance is equal to. Now let's go back to the scenario. This is the graph. So how does the graph look like? The graph is nothing but a trapezium, and the car traveled this region. Okay, this is the region it traveled. This is the region, this as well as this. So it is nothing but a trapezium. If we find the area of this trapezium, that is actually the total distance traveled by the car. So let us find the what is the formula for area of a trapezium. Area of a trapezium is half of sum of the parallel lines. So what are the parallel lines? This line is 1 and the other parallel line is this 2. So first length of the first parallel line is 0 until 60, that means 60, and the length of the another shorter parallel line is from 10 until 40, so it is 30. And then the distance between the parallel lines, so distance between the parallel line is this, which is, how much is this distance? This is 20. We have already written the vertical line represents the distance. So let us write the distance. Total distance is going to be half of the parallel line, sum of the parallel lines. First parallel lines continue 0 until 60, so this is 60, and the smaller parallel line was 30, as I have shown. That means constant speed, the length of the line when the car was at a constant speed, then into vertical distance, perpendicular distance between these parallel lines, that means the velocity was 20, equal to, if we do calculation, how much will we get? 2, it is 10, 2, then if we dissolve 20, it is 10, so 10 90s are 900 meters. So this is what the total distance traveled by the car. That's all about this answer. Let's move on to the next question. I think you have understood. So how to find the total distance? Total distance is nothing but the area of the traveled region. It may be trapezoidal, it may be triangular, or it may be, curvilinear. In that case, we will apply integration formula. I think you have understood these two answers. Let it be copied. You can copy whole of the answer from this. Well, let's move on to the immediate next question.